Hello everyone, welcome to another video. Today we'll be solving Cambridge IGCSE Chemistry Paper 6 Alternative to Practical October-November 20 Paper 63. Question number 1. Hot zinc reacts with steam to make zinc oxide and hydrogen gas. A student wanted to use the apparatus shown to react zinc with steam and to collect the hydrogen. Water and mineral wool, zinc present over here, and then tube A is connecting to this particular boiling tube. There is water and the boiling tube is also stoppered. Name the items labeled apparatus A and B. So apparatus A is a delivery tube and apparatus B is a water trough. Part B. State the purpose of the mineral wool. The mineral wool absorbs and holds the water. Part C. The apparatus shown is dangerous to use because of an error in the way it has been set up. Identify the error. Explain why this error makes it dangerous to use the apparatus. So the error is the rubber bung that is placed in the boiling tube. And basically what would happen is that once the gas would come and fill up this particular boiling tube, pressure would build up and it may result in the boiling tube exploding. Part D. Add two arrows to the diagram to show the two places where the apparatus would be heated once the error in C has been corrected. So the water and mineral wool containing portion should be heated and the zinc should be heated. Part E. Describe the test for hydrogen gas. So hydrogen gas can be tested with lighted splint and the result will be popping sound. Question number 2. A student investigated the reaction between dilute ethanoic acid and two different solutions of sodium hydroxide, solution labeled A and B. Two experiments were done. Experiment 1. A burette was rinsed with solution A. The burette was filled with solution A. Some of solution A was run out of the burette so that the level of the solution A was on the burette scale. Using a measuring cylinder, 25 cm³ of ethanoic acid was poured into conical flask. 5 drops of thermophthalate indicator were added to the conical flask. Solution A was added slowly from the burette to the conical flask while the flask was swirled until the solution just changed color. Use the burette diagrams to complete the table for experiment 1. So we can see initially it was 0 and then after the experiment complete it was 37.2. So final reading is 37.2 and initial burette reading was 0.0. So the volume of solution A that was added was 37.2. Experiment 2. The conical flask was emptied, rinsed with distilled water. The burette was emptied, rinsed with distilled water. The burette was rinsed with solution B. The burette was filled with solution B. Some of the solution B was run out of the burette so that the level of the solution B was on the burette scale. Using a measuring cylinder, 25 cm³ of ethanoic acid was poured into the conical flask. 5 drops of thermophthalate indicator were added to the conical flask. Solution B was added slowly from the burette to the conical flask while the flask was swirled until the solution just changed color. Use the burette diagram to complete the table for experiment 2. We can see the initial reading is 5.5 and the final reading is 17.9. So final burette reading 17.9. Initial burette reading 5.5. Volume of solution B added 17.9 minus 5.5, 12.4. Explain why universal indicator is not a suitable indicator to use in this titration. We know that universal indicator has many color changes in different pH, so it will be hard to determine the endpoint using universal indicator. Part C1. State which solution of sodium hydroxide, solution A or solution B, was the more concentrated. Explain your answer. So, in every case, we are using the same volume of ethanoic acid. In every cases, we are using the same volume of ethanoic acid, which is 25 cm³ of dilute ethanoic acid, the same concentration. However, solution B required only 12.4 cm³ of sodium hydroxide solution to actually neutralize the 25 cm³, whereas solution A required 37.2. Since solution B required less volume, so solution B must be more concentrated. Part C2. State how many times more concentrated this solution of sodium hydroxide was than the other solution of sodium hydroxide. So basically, the first solution required 37.2 cm³ and the second solution B required 12.4. So 37.2 divided by 12.4 is equals to 3. So 3 times more. Part D. Determine the volume of solution B that would be required if experiment 2 was repeated with 10 cm³ of dilute ethanoic acid. When we used 25 cm³ of dilute ethanoic acid, we required 12.4. So now, since we are going to be using 10 cm³, which is 2.5 times less than the original volume that we used in the first time, so the answer will be 12.4 divided by 2.5, which would be 4.96 cm³, equivalent to 5 cm³. Part E. Describe how the reliability of the results could be checked. Whenever talking about reliability of results, we must understand repeating an experiment will produce similar result again and again. And when we compare the results, we can improve the reliability of that result. So we'll have to repeat and compare the result. F. A 25 cm³ pipette can be used to measure the volume of solution. Describe an advantage of using 25 cm³ pipette to measure the volume of the dilute ethanoic acid. So the advantage of using a pipette is that it's more accurate, it is more precise than a measuring cylinder. Part 2. Explain why a 25 cm³ pipette could not be used to measure the volume of solution A. So if we look back at solution A, we required 37.2 cm³. A pipette can only measure fixed volumes. Part G1. Explain why the burette was rinsed with distilled water in experiment 2. So basically, experiment 1, the burette was rinsed with distilled water to remove the solution A from the burette. Explain why the burette was then rinsed with solution B. Well, after washing with distilled water, the burette contained distilled water. So to remove that distilled water, it is washed with solution B. Even a small amount of distilled water can actually dilute the solution that we are going to add. State the effect that not rinsing the burette with solution B would have on the final burette reading. Explain your answer. Effect. So basically, if we did not wash the burette with solution B, then there would be some remaining distilled water. And those remaining distilled water would basically dilute the solution B. So as a result, a larger volume of solution B would be required. And because the water makes the solution B diluted. Question number 3. Two solids, solid C and solid D, were analyzed. Tests were done on each solid. Test on solid C. Tests were done and the following observations were made. Test on solid C. Half of solid C was placed in test tube. The solid was heated gently and then strongly. Steam given off and condensation appeared in the mouth of the test tube. The remaining solid became black. So basically, this indicates two things. First of all, there is water of hydration. And the second thing, because it says this, the remainder of the solid became black, it can be an indication of copper oxide. The remaining solid C was dissolved in distilled water to produce solution C. The solution was divided into two equal portions in two test tubes. Sorry, depending on that particular thing, it cannot be copper oxide. Never mind. Alright, it was divided into two portions in test tube. Few drops of universal indicator solution were added to the first portion of solution C. The solution became orange, weakly acidic. When universal indicator turns orange, it means acidic and it means a weak acid. A spatula measure of solid sodium carbonate was added to the second portion of solution C. Any gas produced was tested. Effervescence has been seen. The gas turned lime water milky. So sodium carbonate, whenever carbonate ion is added to acid, it produces carbon dioxide. So definitely solution C was a acid, that we can conclude, which produced the CO2 gas, and that CO2 gas turned the lime water milky. Suggest the pH of the solution C. Since the pH is of a weak acid, so it could be like 4. Identify the gas produced in test 3. The gas produced in test 3 is carbon dioxide. What conclusions can you make about solid C? So for solid C, we can say that for solid C, we can say that it is acidic and it contains water of hydration. Test on solid D. Solid D was calcium chloride. Complete the expected observation. Solid D was dissolved in water to form solution D. Solution D was divided into 4 approximately equal portions in 4 test tubes. A few drops of aqueous sodium hydroxide were added to the first portion of solution D. Observations. So when we are going to add sodium hydroxide to calcium salt, we are going to get white precipitate. So addition of sodium hydroxide would give white precipitate. And excess of sodium hydroxide was then added to the mixture from D1. Adding excess sodium hydroxide to calcium salt, the precipitate does not dissolve. So we're going to write precipitate does not dissolve. Aqueous ammonia was added dropwise and then in excess to the second portion of solution D. Observation. Now, adding ammonia to calcium salt does not give any observation. So there will be no reaction and there will be no change, and even in excess there will be no change. About 1 cm cube of dilute nitric acid and a few drops of aqueous silver nitrate were added to the third portion of the solution. Dilute nitric acid followed by silver nitrate is a test for halide. So if there is halide present, it should give positive result. And we can see there is chloride present. So because of the presence of chloride, it's going to give white precipitate. About 1 cm cube of dilute nitric acid and a few drops of aqueous barium nitrate were added to the fourth portion of solution D. Observations. Nitric acid followed by a barium nitrate is a test for sulfate. Since this particular salt does not contain sulfate, so there will be no change. Question number 4. A toothpaste contains sodium fluoride, calcium carbonate, silica, mint flavoring. Sodium fluoride and the mint flavoring are soluble in water. Calcium carbonate and silica are insoluble in water. Calcium carbonate reacts with dilute hydrochloric acid to form soluble salt calcium chloride. Plan an investigation to find the percentage by mass of silica in the toothpaste. In your answer, you should include how you will calculate the percentage by mass of silica in the toothpaste. So guys, silica is unreactive with hydrochloric acid as well. So you have access to normal laboratory apparatus. Alright. In an experiment like this, first of all, we need to weigh the toothpaste. So let's say we will take like 10 grams of the particular toothpaste. And what we can do is we can first of all add some dilute hydrochloric acid. Dilute hydrochloric acid is going to do two things. First of all, it's going to remove the calcium carbonate. Alright. Along with the calcium carbonate, it's going to remove the mint flavoring. It's going to remove the sodium fluoride. It's just going to wash it away. Alright. Until we're going to add the acid, until there is no more fizzing that can be seen. And then we're going to filter the solution. Alright, and then we're going to obtain the residue. The residue, we will wash it with more distilled water, and then we are going to leave the residue in the filter paper and dry it in the oven. Then we're going to dry the residue. Then we're going to re-weigh the residue. Alright, we're going to weigh the residue. And then to find out the percentage by mass of silica, we're going to have mass of residue on top divided by the total mass that we have taken into 100%, which will be the percentage by mass of silica. Guys, thank you for watching the video. See you in the next class. And if you like videos like this, please share the video with your friends. Comment in the video which paper you want me to solve next. Any paper of your choice. Please communicate, and then we will obviously solve and post it. Thank you very much for joining today's video.